Hello, thank you for the introduction. Hopefully you see my slides now. I'm going to tell you about really a journey that started for me a bit more than 2 years ago, a little bit after ChatGPT came out, and I was playing with it, and I realized we had really underestimated how fast AI was progressing and how much time was left to achieve AGI was much less than we thought. Already we have machines that basically master language, like basically passing the Turing test, and it would have sounded like science fiction just a few years ago, but now it is here. And so after ChatGPT came out, I realized that we didn't know how to control these systems. We can train them, but we don't know if they're going to behave according to our instructions. And so what happens when they get to be smarter than us, if they prefer their own survival rather than ours? Of course, we don't know, but is that a risk that we can accept? And really what happened to me in January 23 is that I started thinking about my children and my grandchild. I have one grandchild. He was only 1 year old, and I thought, in 20 years, for sure, we will have AGI. We have machines that are smarter than humans. And I was not sure that he would have a life. So I decided to shift my research, my activities, to try to do everything I could to mitigate those risks. Even though it went against many of the things I said before, many of my beliefs, my previous positions, I realized that this was just the right thing to do. So a little bit later, at the end of 2023, I accepted to chair the International AI Safety Report, which put out its first report last January, and comes out of a panel of experts with people from 30 countries, the EU, the UN, the OECD, 30 countries, including, of course, China, United States, and many other countries. And the report looks at three aspects. One is capabilities. So what is it that AI can do, and what can we anticipate based on the trends for the coming years? The second question, of course, is the risks that come with these increasing capabilities. And finally, mitigation. What can we do right now, and what is it that needs to be done in terms of research or societal guardrails in order to mitigate these risks? So in terms of capabilities, it's really important to understand that AI, is moving quickly. It's a big mistake that most people make to think of AI as it is now, whereas we should be thinking of where it will be next year, in 3 years, in 5 years, in 10 years. And of course, we don't have a crystal ball, but the trends are very clear. The capabilities are going up, and I'll show you now the slides, which even gives you more or less a timeline for human-level AI. As many of you know, there's been tremendous advances since in the last year, more or less, thanks to reasoning models that have chains of thoughts that are trained, and that has enabled much better reasoning, better results in mathematics, computer science, and all the sciences. Another important trend that, of course, many people are aware of, but I'll talk a lot about, is agency. There's been a lot of progress in the capabilities of AI, not just to be a chatbot, but also to do things, to program, to do things on the internet, to control computers and appliances, to search the internet, to search databases, to write in databases, and so on. So let me focus on planning, because it is probably the area where, at the cognitive level, AI is most lagging compared to humans. And so it is quite important to track this. And a recent study by Meter shows that the planning abilities are improving exponentially. So in the figure, you see the number of years, the last 5 years, a horizontal axis, and you see the duration of tasks that the AI can complete as measured by how much time it takes by a human. And it's a straight line, but actually the vertical axis is on the logarithmic scale, which means that this is an exponential curve. And the data points, which are the most advanced AIs of the time, they line up almost perfectly on this exponential. So what this says is that the duration of the tasks that the AIs can complete is doubling every 7 months. And if we extrapolate from this curve, we will get approximately human level in 5 years. Of course, no one has a crystal ball. Maybe the progress will stop. But I think from a public policy and business planning strategy, it is, we should at least consider that the trend will continue and see what the consequences are. So what can go wrong? Unfortunately, in the last 6 months, we've seen a number of scientific results which show AIs that have self-preservation behavior and are willing to deceive us, to lie, to cheat. For example, in this paper, the AI reads that it's going to be replaced by a new version, and then it tries to copy itself in place of the new version. And then when asked about it, it lies. It says, "Oh, I don't know what happened." In this paper, the AI is pretending to agree with the human trainer in order to avoid changes that would happen during training so that it keeps its old goals. So it's a kind of self-preservation behavior as well. In this paper, the AI is confronted with two kinds of goals. On one hand, it wants to win the game of chess. It's asked to play the game of chess, but it also has its alignment training, which tells it to not cheat, to be honest. Unfortunately, it realizes that it's going to lose, and so it decides to cheat. It decides to hack the file that contained the board and to win by cheating. And this is the latest result just a few days ago in the system card for Anthropic's Claude 4, where, again, the AI reads in its files, it's able to read emails, and it finds in emails that it's going to be replaced by a new system. And in other emails, it finds that the engineer responsible for this replacement is having an extramarital affair. And then what it does is it tries to blackmail the engineer by threatening to reveal the affair if the replacement goes through. This is really, really bad behavior. So we see these bad behaviors. We see self-preservation. We see AI that is going against our instructions and trying to survive. Now, trying to preserve yourself is sort of normal for every living thing, and it's a result of evolutionary forces. But in AI, there are many possible reasons that I don't think we have completely figured out, but it could come from the pre-training, because in pre-training, the AI is imitating humans, or it could come from the reinforcement learning with human feedback, because this is a place where the AI is trying to get more rewards by pleasing humans. And in any case, whatever the origin of this kinds of behavior, it would be really terrible if we end up creating superhuman AI that competes with humans. So one of the important aspects of what's going wrong here is that the AIs in these experiments have goals that we don't directly and explicitly control. So they have uncontrolled implicit goals. So we need to avoid that. The other interesting thing is all of these scenarios, including scenarios that were hypothetical until recently, but we now start seeing, they're due to the fact that the AI is agentic. In other words, the AI is trying to achieve goals. And if the loss of control scenarios eventually happen, they could be really bad. I mean, many experts and CEOs of companies, including myself, have signed a statement saying that this kind of loss of control could lead to human extinction. Of course, we don't know if it's going to happen. We don't know what is the probability of something like this. But when an experiment could be extremely dangerous, but we don't know if it's going to happen with what probability, we should apply the precautionary principle, just like we do in biology or in other sciences. Okay, so now let's talk about what we can do to better understand this and maybe to look for solutions to avoid these kinds of behavior. Now, if you think about an AI that could do something really dangerous, really harmful, it needs to have the capability, of course, and that is why it is quite important to have capability evaluation. A lot of the risk management of AI right now goes through capability evaluation. What are the things that the AI can do, and can these things be turned into dangerous actions for people, for society, and so on? So capability is not sufficient. You may have the capability of killing, but if you don't have the intention of killing, it's very unlikely that it will happen. So, given the current dynamics in the world and the competition between companies and countries, it's very unlikely that we will globally stop to do research to improve the capability of AI. So then what can we do? Well, the place where maybe we can mitigate the risk is with intention, right? So even if we have AIs that are very capable, if we can make sure they don't have bad intention, if we can make sure that they're honest, then we would be fine. So what can we do about this? This is another figure that explains a similar idea that was presented by David Kruger at the last NeurIPS. In order for an AI to be really dangerous, it actually needs three things. It needs the intelligence. It needs to know a lot of things and how to apply that knowledge. It needs affordances, which means it needs to be able to do things in the world, which could be talk to people, program computers, go on the internet, social media, right, whatever, robots. And then it needs to have goals, and it needs to have goals for itself. So these are the three conditions. And the research program that I have started is trying to explore, can we build AI that has just the intelligence and no self and goals and minimal affordances, because we still want to be able to communicate with the AI. So I call this scientist AI, and it really is deviating from the tradition in AI research. Since the beginning of AI research, we have tried to build AI like humans, taking human intelligence as an inspiration. But if we continue on this path, that means we're going to build machines probably smarter than us, and that means creating competitors to humans, because we compete with each other. And so that could be very dangerous. So maybe it's time to rethink this gospel and think of designing AI that could be useful for people, useful for society, but not endangering us. And so I'm proposing this approach. I've written a paper with the same title on the scientist AI, where the goal is to build an AI that is completely honest, completely non-agentic, based on the capability to explain things. So instead of current AIs which are trying to imitate people or please people, the scientist AI would be trying to explain people. Like instead of having an actor that tries to imitate people or tries to please people, and that could be dishonest and deceptive, think of a psychologist. So why is that different? Well, a psychologist can be considering a sociopath, and the psychologist tries to understand what's going on with the sociopath. What are the causal mechanisms? But the psychologist does not need to behave like a sociopath. But right now, the way we train AI is like us. And so sometimes in some circumstances, it might act in bad ways. The good news that I'm going to try to explain is that even though the building block we want to build is non-agentic, it can serve as a foundation for building safe agentic systems. Okay, so one important question is, if we want to build an AI that is doing just intelligence, just understanding, without agency, what do we need? Well, we need an AI that can generate hypotheses about how the world works, just like a scientist generates hypotheses about how the world works. But that's not sufficient. If you only have the hypotheses, it's not sufficient to make good predictions. You also need to make inferences. In other words, derive consequences of those hypotheses in order to predict the outcomes, for example, of some actions or some experiments. So that's the idea of the scientist AI. And an interesting insight is that even though a scientist AI would be non-agentic, it could be used as a guardrail for agentic AI. So let me explain what I mean here. So the guardrail here is what's called a monitor in LLMs. In other words, it's a separate AI whose job is to predict whether the action or the output or the query is going against our safety instructions. So it just needs to be a good predictor. It doesn't need to be an agent. So that's a good news, because the bad behavior that I talked about, the deceptive behavior, the dishonest behavior, the dangerous behavior, it's all because of agency. When an AI is very agentic, it means it's completely autonomous. There is no human oversight. And that is where we start seeing problems. But a monitor which just tries to predict whether an action is going to be dangerous, it doesn't need to be agentic. It just needs to be a good predictor. And if the prediction, for example, the probability of harm given the action and the context is above a threshold, then we can just reject that action. So in other words, we can use an AI which is not agentic to control another AI which is not trusted and is agentic. So that's a key idea. Another desiderata for the scientist AI is that, to be really honest, it needs to be humble about its knowledge. So it should not claim something that is false. Unfortunately, the way we typically train our AI right now with maximum likelihood can lead to overconfidence at the same time as being wrong. To understand why this is important, consider this little toy scenario where a robot is in front of two doors. And it has to choose, go left or go right. Now, based on the past data, it has two theories that are compatible with the previous data, but it doesn't know which one is correct. The left bubble shows the first theory. The right bubble shows the second theory. So the left bubble, the theory on the left says that if you take the left door, people will die. If you take the right door, people will get cake. That's good. But the other theory, the right bubble, it says something quite different. It says with the left door, people get cake, and the right door, it's neutral. Nothing bad, nothing good. All right, so you should ask yourself, should the robot go left or right? If it goes left, there's 50% chance that people will die. So that's not a good idea. If it goes right, well, maybe people get cake or maybe there's nothing. So it's better to go right. But for this to work, you need the AI to keep all the possibilities of what is a plausible interpretation, what is a plausible theory. And that is unfortunately not what current methods are doing. So it is important that the AI keeps a distribution over interpretations. In our paper last year at ICLEAR, an oral actually, we showed how you can use our GFlow nets, which is a form of variational inference, to learn how to generate chains of thoughts that are good explanations for the next sentence given the previous sentence. And so you can think of it like filling in the missing information that allows to go from the previous sentence to the next sentence. And so it was actually one of the first proposal to train the chain of thought. But unlike the current approaches based on reinforcement learning, this is based on trying to generate a good explanation for the data rather than anything else. And we've been using these GFlow nets to generate all kinds of explanations which can be highly structured. For example, a causal graph. In other words, the neural net will generate a graph by going through each node and each edge and saying, there's a new edge here, there's a new edge here, there's a new node here, and so on. And in this way, you can generate hypotheses that are structured in the form of a graph. And in a more recent paper, we have been thinking about how we can go beyond these works in order to make the chain of thought honest and to reason better. So in this most recent paper we just put on arXiv, the chain of thought is separated. Instead of just a sequence of words, it's separated into a sequence of claims, a sequence of statements, like a mathematical proof has a sequence of claims. And each claim is supposed to be true or false in support of the thing you're trying to predict. So the difference with the normal chain of thought, in addition to having this structure as a sequence of claims, is that for each claim, there's also a Boolean random variable which indicates whether the claim is true or false. And normally when you think about an argument, you assume that every claim is true, but actually sometimes some claims are more certain than others, and so you want to be representing the probability of each claim. So the idea is, again, going back to what I was saying, that the AI is not going to try to imitate the text that people write. It's going to try to find explanations for that. And an explanation should be structured like a mathematical proof. It should be structured into claims, and each claim is supported by previous claims. And the AI needs to compute the consistency of these claims, the probability that they're correct, so that it can draw correct conclusions. And the good news is that we can train these kinds of systems using latent variable models, similar to what we did last year. Okay. So I've talked a lot about initially the risks due to AIs that are agentic, but in a way that we don't control, and that could lead to loss of human control. But of course, there are many other potentially catastrophic issues as we build AI that is more and more powerful. For example, a very powerful AI could help terrorists to design a new pandemic. And in fact, I learned recently that you could create pandemics that are so powerful that there's probably no cure. And that might even kill not just humans, but most animals. This is really terrible. And biologists think they know how this could be done. And one day it's very likely that AI will know how to do it. And if some bad people get access to this kind of AI, they could really create, huge damage on this planet. So that's of course extreme, but it is totally plausible scientifically that we get to that point. So in order to avoid these kinds of things, we need to make sure that AI will follow our moral instructions. For example, to not give information that can be used to kill people. And of course, to follow our moral instructions to do no harm and to be honest and to not cheat and to not lie and so on, right? And right now, unfortunately, it doesn't work. We don't know how to do it. So this is a scientific challenge, and we need to figure it out quickly. We need to figure it out before we get to AGI. And that could be anywhere from a few years to maybe 1 decade or maybe 2, but most experts I know think it could be, very, very short. It could be even within the next 5 years. And you remember the curve I showed you at the beginning, suggesting that we get more or less to human level in 5 years. So we don't have a lot of time. We need to invest massively to discover the scientific solutions to this alignment and control challenges. Unfortunately, even if we figure this out, it is not sufficient, right? Because even if we know how to make AI that is safe, for example, with a guardrail that I talked about, well, it doesn't mean that we don't have any problems, because someone could just remove the piece of code that contains the guardrail, and then the AI can be used to do bad things. And unfortunately, the coordination between companies and between governments around the world is not working right now. There's competition between companies. They're racing to be at the top. There's competition between countries. They also want to be at the top. And as a result, there's not enough investment in safety, in how to make sure the AI will not be used to harm people or will not lose control of AI. So we need more national regulation. We're starting to see a little bit, but there's also a lot of pushback from companies against regulation. And of course, national regulation alone is not sufficient. We need to make sure all the leading countries who are developing AI agree on some principles. Unfortunately, they see AI as a tool, as a weapon against each other. And so it's very difficult to get into this mode. The only way to really get around the same table is to realize that for these really catastrophic outcomes, like loss of human control, like the use by terrorists, well, it doesn't matter in which country it happens. We all lose. We are all in the same boat, right? So whether it's a rogue AI or a terrorist using AI, everyone loses. So when governments around the world, especially the US and China, understand this, I think we can make progress. But until we stay in this idea that we're going to use AI against each other, we're stuck. And finally, even if we intend to find a political solution, it's not sufficient. We need to develop new technology for verifying that AI is used properly. Because, think about nuclear agreements. They are all of the kind, trust but verify. And so we need verification technology, for example, at the hardware and software level, using advanced technologies, which I think can be designed and some people in the world are working on. So I'll stop here. Thank you for your attention. I hope you take the time to digest what I've been talking about.